So here's the story of how the command line developed. I was, in 2004, I had to interpret the command line, and I didn't like Unix scripting. It was a language I never learned, I never liked it, so I said, what if I use C as the scripting language? So we can do directory star. What if I add default parameters from C++? So then I said, what if I, why do I need those parentheses? Why don't I make those optional? So that's how the syntax developed. So this is actually this actually feeds into a C compiler, Holy C, line by line feeds into a compiler. If you say, well, I modernized everything. God's temple must be perfect. So let's say if we want to count and let's just do it this way. So it's feeding line by line into a compiler. Just for now, I'm going to use this printf. Okay, so I just entered a function. It feeds line by line into a compiler. If there's a statement outside of a function, it compiles function by function, and if there's a statement outside of a function, then it executes immediately. So what we have, this minus, we don't want to recurse. In our environment variable symbol table, we have a function count. It's residing in memory. I made a 64-bit compiler. You can see it's using N as a RDI for a N and RSI for I. It's using local variables, and it puts string constants just after the function. I happen to use the Intel return and pop, and I use the leave. These are some little known function or instructions, but it's okay. So we can say so these are all the tasks that are running. These are child tasks of this task up here. I made so if a symbol is not found, it checks the parent. So CPU 0 is special. This is not symmetric. An application, well, anyway, Adam is the father of all tasks, like Adam and Eve. When it boots, it's Adam. Adam is the first task, and then he has children. Guess what? Let's go to the so this file right here is what's executed by Adam during boot, and it includes some headers, and then it goes to the Adam directory, and so this is like auto exec, and what it does is it fills up Adam's symbol table. This docmax is going to make so I have infinite command line buffer, and then we're going to say who with recursion. So these are all the symbols that are in Adam's table. So you never need to use an include header file because you execute everything just in time. It's compiled, not interpreted, and all these symbols are already waiting in the symbol table. So it's really elegant the way it works. Let me explain a couple other things. So I made some simplifications. If a string is encountered, it's sent to printf. So this is a hello world. You can even go shorter than this. The shortest hello world is like this. This is hello world. So we say pound. Remember, it's feeding into a C compiler, holy C. If it ends in Z, it's compressed. Now I have to put a semicolon. Hello world. So that's the shortest. Then we can go a little bigger. Oops. So now we do it again. I can come up off the bottom. Hello world. So we can do multiple mains. I shortcut this. You can hit enter on the directory entry, and it just did the pound include. So what I did is I made the editor the same for the command line as for documents, so the command line has links and macros, and now since we're coming up off the bottom, it doesn't do command history. So guess what I did? I said, what if I make a document for command history? So if you press Control M, the inspiration for this menu was the command line history. So these are macros. Macros, left macro. So these are macros. And it's the same. If you hit Control T, those are links. So you have links, and these blue ones are macros. So source code has links and trees and graphics. So this is a line count for all the directories. My compiler operates just in time or ahead of time. You never need to operate ahead of time. A normal user only does just in time. And with just in time, you don't have object files or executables. It's good compilation. It's not crappy. It's not interpreted. Anyway, the two things that are compiled ahead of time are the kernel, 24,000 lines, and the compiler, 20,000 lines. The compiler has an assembler and unassembler. So the total is 100,000 lines. Actually, that's the limit. Actually, we're over that because we have applications and demos. I jumped ahead of myself. In the kernel directory, Adam, autoexec.bat, he runs this program. He starts compiling. So see how this is really elegant, how everything is simple. Anyway, it turns out that it's multitasking. Now, remember, you inherit symbols of parents. So if this guy has an I64I and this guy has I64J, there's no I and there's no J, obviously. But what if we tell Adam is the father of all tasks? He's kind of like, since he's special, he's the father of all tasks. So we tell him to do stuff. So we say, Adam, we tell him I64K, create a variable called K. It's not showing. I have to say, Adam, I'm going to tell Adam to say hi. There, Adam said hi. So we declared a variable K. Now, guess what? K equals 1, 2, 3. If we come over here, K, he has K. So you can make dynamic link libraries and global variables really easily. If you want to make a dynamic link library, then you go to your, okay, so the kernel auto exec is Atom 1. It ends with Atom 2. So Atom 1 includes the headers for the compiler and kernel. Atom 2 includes another half of the operating system that's not the kernel. It just includes. And when this ends, it goes into your account and does Atom 3. So there's an account directory. This is like home, I guess, in Unix. So in the account directory, what you do is you put include if you want a DLL. So now, guess what? Parent, or if it doesn't find a file, it checks the parents. So I actually go with TS for, that's my company, and then my name's Terry Andrew Davis. So I have my personal account files, then my company files, and then there's the system default account files. So if there's no path, if a file's not found, it checks the parent. You don't really. What we do is we go ahead and include everything as a DLL pretty much. All the utilities are included as DLLs. So grep is sitting in memory. Unassemble function grep. Yeah, it's sitting right in memory. It got compiled during boot. During boot, 46,000 lines gets compiled, and then I can recompile. This is make all. This compiles the other half, the kernel and the compiler that we looked at. So remember, there's 100,000 lines. It compiles. You don't have make files. What you have are just, this is kind of like compiling a.out. You don't have object files. You just go straight to binary. You have no business doing this except if you want to work on the kernel. I don't want other people making more binary modules. The compiler and the kernel are the only ahead of time binaries we need. That makes a binary. Otherwise, everything's just in time. Just in time is wonderful. It's just like hitting F5 when you run a game. Like I'm going to run my flight simulator. This is a 8-core flight simulator. I'm saving 8 frames to disk per second. So my screen is actually a little better than what you're seeing. So someone wanted to see a barrel roll. Anyway, it's supposed to be an eagle diving for fish. So 8 cores. It's not symmetric. It's master-slave multi-core. So anyway, how about that?